everyone. Today in geometry, we're going to continue talking about our Unit 10, Day 3 application notes. So we're on question 7. So a rectangular fish tank has dimensions. So let's draw our fish tank here. And my dimensions are 14 by 16 by 12. So 16 by 14 by 12, and those are all in inches. And it has 1,680 cubic inches of water already in it. All right, so water is already in the tank. Okay, but I want to know what percentage of the tank is empty. All right, so we got to do two things here. We need to find the volume of the tank when it's full. So we want to find the volume of the tank. So we're going to use length times width times height. So 14 times the 16 times the 12. And I multiply that together and I get 2,688 inches cubed. All right, now we know that it has 1,680 cubic inches of water already in it. So if I subtract those, I end up with 1,008 cubic inches of water. And if I want to find the percentage, I'm going to divide that by the entire tank. All right, so let's take 1,008, divide that by 2,688. I want to make that a percentage, so multiply that by 100. So it means it's 37.5% empty. Now, if 1 gallon of water holds 231 cubic inches, how many gallons of water does the fish tank hold? So if I take my 2,688 and I divide that by 231, we end up with 11.63 repeating gallons. All right, now letter C. You want to go buy a fish for a fish tank. Now, the method of determining how many fish a tank can hold is 1 inch of fish per gallon of water. So we're going to assume the tank is full, and we want to fill it with neon tetras, which are about 1.5 inches each. I want to know how many fish should I purchase. So if 1 inch is 1 gallon, well, this is a 1.5 inch fish, so that's going to be 1.5 gallons of water. So if I take that full number we had up there, my 11.63 repeating gallons, and I divide that by 1.5 gallons, I get about 7.75 fish. Now, since we don't want to have too many, this would then have to round down to 7 fish. All right, number 8. Now we're talking about Joe's 2 fish tanks. So Joe's larger tank is completely filled with water. Then he takes water from it to fill a smaller tank. So we want to know how many cubic inches of water will remain in the larger tank. Now, the diagram here is missing. All right, so in my larger tank, we have about 30 inches by a foot by 18 inches. And in my smaller tank, sorry, this is my larger tank. Oopsies. No, not 1.5 feet. Oh, only by 6 inches. Okay, but by 12 inches. All right, so it's my smaller tank. All right, so what I want to do is I want to find the volumes of both my tanks. So the volume of the larger tank. So length times width times height. Now, one thing we noticed is that my units are not all the same. So it might be easier just to put them all in inches, right? So we need to convert to inches. Okay, and then the reason I'm picking inches is because I want the cubic inches of water here. So there's my 12 inches. So I've got 30 times 12 times 18. It's going to give me 6,480 inches cubed. In my second one, we've got our 12 inches times our 6 inches. And right over here, my 1.5 feet is going to give me 18 inches. So 18. All right, so finding that volume, I get 1,296 inches cubed. All right, so this is my large one. This is my small one. So the volume of large minus my volume of my small. So 6,480 minus 1,296. I get 5,184 inches cubed. Okay, and that's left in the large tank. So now it wants to know what percent to the nearest hundredth of a percent of Joe's larger tank is empty. All right, so I know that I took out 1,296 inches cubed out of the 6,480 inches cubed. And when I divide those, I get 0.2. Now multiply that by 100 to make it a percentage, and I get 20. So this is 20%. Now, since this is nearest hundredth, though, I am going to put a 0.00 on the end. All right, number 9. A pharmacist is filling medicine capsules. The capsules are cylinders with hemispheres on each end. Okay, so we have this, this, and this, if I draw it two-dimensionally. Right? And the length of the cylinder is 12 millimeters, and the radius is 2 millimeters. I want to know how many cubic millimeters can the medication of one capsule hold. All right, so what we want to think of is the volume of my cylinder. So my pi r squared h. And then I've got 4/3 pi r cubed. And since we have two hemispheres, that's going to give us one sphere. All right, now the length of the cylinder is 12. The radius is 2. All right, so the volume equals pi. Now my radius is 2, so 2 squared times my height of 12 plus 4/3 pi times my radius cubed. All right, so 2 squared is 4 times 12 is going to give me 48 pi. And 2 to the third is 8. And 8 times 4/3 is going to give me 32/3 pi. Okay, so my calculator, we've got 48 pi plus 32/3 pi. And I get about 184.3. All right, stay tuned for the next part of the notes.